Learning Target 8.7 says I can use the ideal gas equation to solve problems. Now you'll also need to explain the difference between a real gas and an ideal gas. So let's look at that. Alright, so what is an ideal gas? It's a gas whose particles take up no space and have no intermolecular attractive forces of any kind. Okay, in other words, the gas particles are not attracted to each other. They have no charge. They're neutral. Okay? When does the ideal gas law not work for a real gas? When you have very, very high pressure or very, very low temperatures. We do then have to take into account the volume of the particles as well as the intermolecular forces. So at high pressures and low temperatures, then the real gases do not act as ideal gases. So you just need to know when that happens. So the formula is PV equals nRT. Fairly simple formula, but these variables are very specific. So I've created this table for you. You can just pause the video and jot it down. So P stands for pressure. And the units of the pressure can vary. Alright, we can use ATMs, kilopascals, torrs, or even millimeters of mercury. V stands for volume, and that unit must be in liters. Has to be in liters. So if you have milliliters, you have to change it. N stands for moles. Of course, that's in moles. Now, R is what we call the ideal gas constant. And its unit is going to depend on pressure. So we will look at the ideal gas constant separate. T stands for temperature, and this must be in Kelvin. Alright, so you always have to have liters, moles, and Kelvin. The pressure units, as long as P and R go together, then you're okay. Alright, so let's look at what some of this means. Going to depend on the pressure unit. It is based on standard temperature and pressure and 1 mole of gas. If we rearrange the equation to solve for R, you get the pressure times the volume divided by moles times temperature. So that's how they calculate it. So if your pressure is ATM, your R value is 0.0821. If your pressure value is kPa, you use 8.314. And if your unit is millimeters of mercury or torr, remember those are the same, you use 62.4 liters. So how in the world are you supposed to know all these? Of course, you do not have to sit down and memorize them. You're going to get out your handy dandy little reference packet. So we're going to look at the first page of your reference packet and notice that we see right here this gas constant R. Okay, sorry, I'm playing a little bit. So there's R. So anytime you're going to use PV equals nRT, you're going to have to know this value. Now notice that when we have ATM, you have 0.0821. Okay, when we have millimeters of mercury, you have 62.4, and when we have kPa, you use 8.314. So here's where you're going to find all of your values, okay? And what you might want to do is, just so you don't forget, write PV equals nRT on your reference packet right there where you'll remember where to find it. Okay? Let's look at some example problems. Now, notice that as I read, this has been underlined. Okay, so if I have 4 moles of a gas at a pressure of 5.6 atm, a volume of 12 liters, what is the temperature? So I'm going to circle temperature. That's what I'm looking for. Okay, so now I'm going to label. Moles uses N. ATM, that's my pressure. Liters is my volume. And I'm trying to find temperature. Now, anytime you see moles, that is going to be a big clue that you use PV equals nRT. Okay, and these are different from the combined gas law problems where you had 2 pressures, 2 volumes, or 2 temperatures. So now we need to decide the R value. Okay, so looking at my pressure unit, I see that I have ATM. So if I look back, I see that when I use ATM, I use 0.0821. Now these units here are so that all the other units in the problem will cancel. Alright, so this whole unit we'll use in a little bit. So the R value we're going to use is 0.0821 liter ATM per mole times Kelvin. Okay, so my formula is PV equals nRT. Now you can do this one of two ways. You can either rearrange the equation to solve for T, or you can plug in the numbers and then rearrange and solve. So if you rearrange the equation to solve for T, you get P times V over N times R. And then you plug in your numbers. Okay. Or, like I said, you can plug your numbers in and then rearrange. Either way is going to work. So when we plug our numbers, I'm going to just go ahead and plug my numbers in here. We get 5.6 times 12 over 4 times 0.0821. Now notice I left out the units. The units just kind of help you figure out what goes where. Double check, make sure you have liters. Okay, we did that. Double check to make sure your atmospheres goes with R. Alright, and then we're going to be very careful with how we put this in our calculator. Okay, you need to do all of your multiplication before you do your division. Otherwise, you're not going to get the right answer. So in your calculator, you either need to use parentheses, 5.6 times 12 divided by, use some more parentheses, 4 times 0.0821 that way, okay, or you need to do those problems separately. Either way, you should end up with a temperature of 205 Kelvin. Our next example, we have an unknown quantity of gas at a pressure of 102.5 kilopascals, a volume of 31 liters, and a temperature of 87 degrees Celsius. How many moles of gas do I have? Now we want to label. So kPa is pressure, liters is volume. Now degrees Celsius is temperature, but we have to add 273 to take it to Kelvin. Alright, so make sure that you do that and you end up with 360 Kelvin. Okay, now moles is what I'm trying to find, so that's N. So I see that my formula is PV equals nRT. So I need my R value. Okay, so my pressure is in kilopascals. So if I look at my reference packet, I see kPa. I use 8.314. So R is 8.314, and that's liters, kilopascals per mole Kelvin. Now we're going to solve for N. So again, you can either plug your numbers in or you can rearrange. So N is equal to P times V over R times T. Plug in your numbers and you get 102.5 times 31 divided by 8.314 times 360. Okay, so remember to use parentheses and put this in your calculator correctly, and you end up with 1.06 moles as your answer. Example number 8. We have 3 moles of gas in a container with a volume of 60 liters at a temperature of 400 Kelvin. What is the pressure in ATMs? Okay, so moles is N, liters is volume, Kelvin is our temperature, pressure is what we're looking for. Now it's important that they told us this was ATM because that's going to help us determine that R value. Okay, so PV equals nRT, R value for ATM. Okay, look at ATM, you use 0.0821. Okay. Now we're going to plug in all of our numbers. We're going to solve for pressure. So pressure is nRT over V. Okay, so I'm going to do this down here where I've got a little bit more room. So N is equal to 3 times our R value, 0.0821, times our volume of 60 liters. Oh, sorry, I messed that up. Times our temperature of 400 Kelvin, and we're going to divide that by our volume of 60 liters. So when you put all that in your calculator and punch it out, you get 1.65 atmospheres as your pressure. One more example here. We have 7.7 moles of gas at a pressure of 9.12 kPa and a temperature of 56 degrees Celsius. What is the volume of the container? So moles is N, kPa tells me pressure, 56 degrees Celsius tells me temperature. But remember that temperature must be in Kelvin. Alright, so that is going to be 329 Kelvin. And we're looking for volume. So our formula is PV equals nRT. We look at P, we see we have kPa. So kilopascals, we use 8.314. Now we plug it in for volume. So volume is N times R times T over P. So we get 7.7 times 8.314 times 329. Divide that by our 9.12 kilopascals, and you get a volume of 2,309 liters.